Okay, so out on Blackboard under take-home assignments, you'll see second assignment, spring 2014. If you click on that, you'll notice that it's a folder, okay? It's not just the assignment, it's a folder that contains multiple things. And the first thing it contains is our assignment, which I'll open in a second. The third thing it contains is a link, a course link, to where you'll get the Excel files. All these assignments, all these problems are out of the book, not the web exercises, but in the book itself. Okay, so this is book Excel files. And we're using two workbooks, if you will, to do estimation and hypothesis testing. Here they are, okay, estimators and teststatistic.xls. So they're available to you right here as well. After I record this YouTube video, I'll probably slap it in this folder as well, so then you have every piece of resource that you could need to get this done. Okay, so let's take a look at our second assignment, spring 2014. Okay, so it is due next Tuesday, April Fool's Day, and it is worth 25 points. Okay, so let's go back to the first one. And let's look at page 166. And I would like you to do 11 and 12. Okay, 11 and 12 and 14. All of these, and I can tell you that, all of these are inferences about a population proportion. Okay, these first three in chapter 10, these are all inferences about a population proportion. These are hypothesis tests of a population proportion. Okay, so what the hell? I'll do one. Let's do one. Okay, let's do number 11. Okay, so number 11 says a professor of business stats recently adopted a new textbook. At the completion of the course, 100 randomly selected students were asked to assess the book. The responses are as follows: excellent, good, adequate, fair, poor. Or I added fair, but it's just poor. The results are stored using the codes in parentheses. Do the data allow us to conclude at the 10% significance level that more than 50% of business students would rate the book as excellent? So I'm looking for a hypothesis test of the proportion. So this is a hypothesis test. So what I'm going to look for is, hey, I need to use teststatistics.xls. Okay, that is all I use for hypothesis testing, teststatistics.xls. There is one that says z-test proportion. Okay, z-test proportion. And here's what we need for z-test proportion. We need the sample proportion, we need the sample size, we need the hypothesized proportion, and we need alpha. Okay, so going back to this, what I'm trying to prove is at the 10% significance level that at least 50% of the people find the bookstore service to be excellent. Okay, so there's a couple things I know. I know the significance level, alpha is 10%. I know the hypothesized proportion is 0.5. There's a couple things I need though. I need the sample proportion and I need the sample size. How am I going to get those two things? How am I going to get those two things? How am I going to get those two things?
Pivot table.
Okay, pivot table or COUNTIF, right? Let's go to the data. So I'm going to go to the data, book Excel files, book Excel files. This is chapter 10. Thank you. And this is number 11. And here is the data. Okay? A couple things I can look at and know right away is looks like my sample size is 100, right? N is equal to 100, right? Because there's 100 samples in here. 4 means excellent. So I want to count the number of 4s. So I can do it a couple different ways. I can sort it. I can do a COUNTIF. Let's do a COUNTIF. If I do COUNTIF, count if A2 to A101, and I want to count the number of 4s. That gives me is that all there are?
I think we want to do one.
Huh?
I think we're looking for the number one.
1 min, excellent. Okay, thank you. So count the number of ones. There's 57 ones, okay? So 57 out of 100, that's not a difficult percentage to figure out. 57 out of 100 is what? 57%. Or I could have highlighted A, insert, pivot table, drug textbook to the rows, drug textbook to the values. I see 57 ones here as well. If I wanted a percentage, I could drag textbook down here, and instead of saying count, I can go to value field settings, we've done this before, and say percentage of grand total, and it will give me that proportion. So, I don't care how you get there, okay, but you need to figure out the sample proportion and the sample size in order to use teststatistics.xls. Let's go back to teststatistics.xls. And our sample proportion was what? What was p hat? 0.57. Our sample size was 100. Our hypothesized proportion, we're trying to prove it's greater than 50%. Our alpha was it 5% or 10%? I can't recall. Was it 5%? Okay.
10%.
What's that?
It was 10%.
It was 10% in the book? Yes, it was 10%. So we're going to change that to 10%. And all we need to look at, one-stop shop, okay? What one value tells me if this is enough evidence to make this claim. There's one value and one value only. What value is that? Anyone?
P-value?
The p-value, which in this case is what? 0.0808, right? That's the p-value. The p-value for a one-tell test. So I would highlight that. Here's what I would do. I would take this, I'd highlight this because that's really the important thing. Maybe I would copy this into my Word document that I'm building. I'd paste it over here. And I would say, there is enough evidence. I would write a sentence. There is enough evidence at the 10%. 10% significance to conclude. Oh, I'm sorry, I'm having trouble typing, but to conclude at the 10% significance level that the percentage of people that said the bookstore is excellent is greater than 50%. So for every problem, okay, I want one or two sentences of you interpreting the results or your conclusions, right? So one or two sentences, it doesn't have to be a paragraph, but one or two sentences saying, hey, there is enough evidence to make this claim, or there's not enough evidence. You can say it in stat-ease, you can say it in English. You can say, I would make decision one, reject null in favor of alternative because there is enough evidence or not enough evidence. Does that make sense? So all the ones in chapter 10, that's the method you're going to follow. Those are z-test of proportions. Any questions on that? Any questions on this? Okay. Let's look at the ones in chapter 11 then. Okay, so let's go back into okay, so I assigned only 3 from chapter 11. Let's take a look at those. These are on page 181, I believe. So I think I assigned, 11, 13, and 14. Okay, so let's look at those, 11, 13, and 14. So 11 says, to help estimate the size of the disposable razor market A random sample of men was asked to count the number of shaves that they used each razor for. Assume that each razor is used once per day. Estimate with 95% confidence the number of days a pack of 10 razors will last. Okay. So a couple things. Am I estimating here or doing a hypothesis test? Estimation, right? Estimate. I mean, it's a word right there. I'm estimating with 10%. So I'm estimating. If it says prove, or is there enough evidence to infer, what is that? When it says those things, what are we saying? Hypothesis test. So this is definitely an estimation, okay? So if we go to Blackboard, okay, remember there are two files that we have in Blackboard under take-home assignments, under second assignment. We have estimators and test statistics. Which one am I going to use here? Which one am I going to use, under estimators or test statistics? I'm going to use estimators. Okay, we're doing an estimate. So I bring this up. Now, did it give me the population standard deviation in that problem? Did it give me the population standard deviation in that problem? It did not. So because, and I don't think any of them do, because it does not give you the population standard deviation, what am I going to have to use? What?
Data analysis.
Okay, eventually, yes, but of this, I can't use the population standard deviation, so I'm going to use what in place of that? The sample standard deviation, right? And if I don't know the population standard deviation, I have to use the sample standard deviation. What curve do I have to use?
The T-curve.
The T-curve, very good. So you'll see, we're not going to use Z-estimate mean because we don't know the population mean. We're going to use, or the population standard deviation, we're going to use T-estimate mean. Okay, T-estimate. And when we look at T-estimate mean, it says, hey, on the input side, here's the things I need. I need the sample mean, I need the sample standard deviation, I need the sample size, and I need the confidence level. Well, the sample size is pretty easy. That's going to be n, right, the number that I sample. The confidence level is pretty damn easy. I think it told me in the problem it needed, what, 90% confidence or something like that. Where am I going to get the sample mean and the sample standard deviation from?
The descriptive statistics. Data
Right.
analysis.
Right. If I go into, and we did this before, if I go into, I'm just going to make up some data, because I'm not going to do this one for you. I don't want to do them all for you. But if I just said this was, let's say this was the data. It's not, but let's say this was the data. 5, 6, 7, 8, 3. Where do I get the sample mean and the sample standard deviation? I can go up to data, data analysis, descriptive statistics, click OK. I say my data is from A1 to A7. There are labels in the first row, new worksheet reply, summary statistics. I click OK. It comes back and it gives me my mean and my standard deviation. Where is my mean? My mean is where? It says sample mean, or it says mean. My standard deviation is 2.3. So if I went back to that T estimate mean, I would plug in the sample mean, I'd plug in the sample standard deviation, I'd plug in the sample size, I'd plug in the confidence level, and over here it would give me the confidence in it, right? You guys follow that? Okay. Now let's look at, what else did I give you? I said 13 and 14, right? 13 is another estimate, so I would do the same process that I just did for 11. But 14, let's read 14. Companies that sell groceries over the internet are called e-grocers. Customers enter their orders, pay by credit card, and receive delivery by truck. A potential e-grocer analyzed the market and determined that to be profitable, the average order would have to exceed $85. To determine whether an e-grocery would be profitable in one large city, she offered the service and recorded the size of the order for a random sample of customers. Can we infer from these data that the e-grocery will be profitable? Am I doing an estimate here or a hypothesis test? Can we infer? It's a hypothesis test, right? Did it give me the population standard deviation anywhere? No. So I have to use the sample standard deviation. And if I use the sample standard deviation, I have to use what curve? Not the z curve, but the t curve. So going back here, okay, going back here. If I go to, material by chapter, take-home assignments, second assignment, spring 2004, test statistics, because this is a hypothesis test. I'm going to bring up that file test statistics. I don't want to do z-test mean. I want to do t-test mean, right? You guys just told me I'm going to use the t-curve. The same way I get the data when I'm doing t-estimate mean is the same way I get the data when I do t-test mean. I need the sample mean. I need the sample standard deviation. I'm going to use data analysis, descriptive statistics to get those two things, right, like I just did. The sample size is obviously the number I sample. In this case, the hypothesized mean would be what? I'm trying to infer that it's greater than 85. So the hypothesis mean would be 85. And the alpha, did it give me an alpha? I don't know if it gave me an alpha. If a problem doesn't give you an alpha, assume it to be 5%. Okay, assume it to be 5%. Okay, so those are the 5, maybe 6 problems. I think I did one of them and led you on to a lot of the other ones. So those are due Tuesday, a week from today. So I recorded that process. So if you're, and I'll put it under the thing. If you forget, have some issues, okay, you can refer to that